I want to take you 400 years ago. You are having fun, have a party, and you invite many important people, but you also invite entertainment, something cool to see, to have. So you invite magician, maybe mentalist, but you're also gonna invite to your party electricity guy. Why? Because the phenomenon of electricity was not clear. People did not understand it, and for them it was kind of a magic. Putting charge on this pole, and I'm gonna put also charge on this pole. And when I'm gonna put them really close by, we're gonna see some phenomena. We're gonna see that I can swivel it around. Let's stop it. I can apply force without touching. So I could do like kind of a, you know, a show that with my thinking I can move this stuff with this special thing, but it's actually a scientific thing. It's actually a force, and we can use this force. The electromagnetic force is what actually make your car move and other stuff in our life. So let's do the first question, and the first question is gonna be really similar to this concept, this idea. I'm gonna move stuff, especially we're gonna do a marvel. So we're gonna do some marvels. So the first question is gonna be on a table. So in order to draw table is a two-dimensional, right? So I need two axes. So I'm gonna do here y-axis and here x-axis, and here in the middle I'm gonna put a marvel that can roll and move when a force apply on it. Yes. So here we're gonna be marble named A. Okay. And let's do a table just for you to understand what is the given data. So marvel A, this is gonna be name. Marvel A have charge, some charge, and the amount of charge that marble A have is 5Q. Okay, somebody come to the place and put charge on this marble. You can do it by rubbing stuff, you can do it by putting a battery. There's many ways to put charge, okay? But you put some amount of charge, and what is the location of this marble?
The origin.
In the origin, which is the easiest location to write, okay? I'm gonna put another marble. I'm gonna put marble B in this location, -3 and +4. So in this location, they're gonna be marble B. I want you to note that marble B look a little bit smaller, not because it's really small one, because it's a way for me to show to you the little charge in this one, okay? Good, this is B. This is A, and the location is, guys, what's the x coordinate? -3, thank you, and 4. The more you're gonna be involved emotionally in this tutorial, you're gonna remember stuff, and it's gonna be fun for us. Okay, cool. Last but not least, we have C, which is gonna be big, and you see the color that I'm drawing? It's a way for me to notice that this one have another sign to the charge. It's going to be negative, okay? It's a method that I use. You don't have to use it. It's not formal or something, but for me, when I draw, sketch a little bit question, it's helping me solving fast, okay? So this is the tip, okay? And this marble, you note that I put it a really big one, so it's because it's have a lot of charge, 20, okay? So the impact of this marble going to be huge. And the location of this one is actually at height 8, and this distance gonna be, this is 8, and this is 6. Okay, so we have here 8 and 6. Okay, so this is all the given data. And the first question I want to ask you, the first one, is if only marble B and marble A were exist in the world, only these two marbles, what was the force that marble B apply on A? Okay, and I remind you from physics 1, force is a vector. So this is the question we need to answer. Okay, and for that you don't need to think too much. There's a formula that was given in the lecture, and right now I'm going to give it to you. So the formula for a force that someone apply on me because of electrical phenomena is the following. First of all, I'm looking, who is the one that's gonna suffer from the force? A, right? A gonna feel some force, that's what I'm looking at. So I'm gonna write firstly, QA, the first term. The second term is a big term, which we're gonna refer later on, okay, is this term, and we have here a constant, K. K, what you need to remember, it's really big, okay? Its size is 9 to the 10 to the 9. It's really huge, okay? And I want to remind you, the exam gonna be multiple questions. So don't firstly put this number. Maybe the question gonna be only with this K, so look carefully, and you can leave it there as K. Okay, so this is a big number, and it's come from experiments. And here we're gonna put the other charge, QB, divided by this magnitude to the third, and here there's a vector, right? All what I write until now was a scalar, right? There's no direction, and we know that force have a direction, okay? So here it's gonna come the direction. So the direction is the location of the one that's gonna suffer from the force, right? It's applied on him, minus the one that's doing that. Sorry, B. Got it? This term. And here we're gonna have the same thing here. But note, this is not a vector, this is only magnitude. Got it? So we need to solve this equation. We got everything we need in the table above, right? And I'm gonna give you my tips how to solve it. So in order not to confuse, the first thing we're gonna do is deal with this guy. Understand what is this vector. So RA is actually 0, 0, easy. And B is minus 3 and 4, right? Minus 3 and 4. Perfect. So minus and minus cancel, we got plus 3. And minus with 4, we got minus 4. And now I know this term. But look, the step to get this term is really easy. Just do a magnitude and raise it to the power of 3. That's all. So I look at this term, and I'm going to find what is magnitude. So what is the magnitude of this vector? It's according to the Pythagorean theorem, right? Pythagoras. 3 to the third plus 4 to the second, right? 3 to the second, 4 to the second, equal 2, and this is a famous one, 5, right? Perfect, good. So we got this term and this term, right? I'm moving to this board. Cameraman, thank you very much. So the force is A on B is equal to, now we can put the charges, right? So what is QA? Help me, guys?
5Q.
Yes, it's 5Q, good. We have K. We got the charge of B, right, which is only Q, thank you. Down there we need to put 5 to the third. Remember, it's not a vector. And multiply by the vector, right? Which vector is 3 and minus 4. That's it. We got the result. Now we're just going to massage it a little bit, make it look better, right? So this 5 goes with this 5. This becomes K Q to the second, 5 to the second, 3 minus 4. Great. And you know we can arrange it a little bit. Okay, this is already a good answer, yeah? But sometimes it's really nice to present the magnitude and the size separate, right? That's what we do with vectors, right? To have a good intuition. So what I'm going to do, the magnitude of this vector is 5. So if I'm going to divide it and multiply by 5, I'm going to normalize this term. This is going to die out with this, and then we're going to have K Q to the power of 2 divided by 25 multiplied by, I want to emphasize that, 6,3, which have a plus sign, and we also have minus 3, which have a negative sign. And that's what I want you to see. I want you to see that after you finish question about force, especially the electrical force, you must check, is the direction make sense? If we have two particles that have the same charge, the same sign of charge, plus and plus, they're gonna repel each other. Also minus and minus gonna repel each other. Yes, and if they're gonna have opposite charge, they're gonna attract, right? So we're gonna look at this, and I don't know what is the charge, right? I don't know what is the charge of B, I don't know what is the charge of A, but I know they are the same, right? They multiply by 5Q and Q, right? Cameraman, see me? Okay, so I know they're gonna what do? A gonna repel B, but B gonna repel A. So let's see if this makes sense. So it's gonna go in the positive direction of X, good for us, and it's gonna go in the negative direction of Y, good for us. We kill this question. Any question? Yes. If what?
The F on the left side it's flipped.
Flipped? Minus sign. Gonna fix it. Right?
B on A.
Right? And then you have a negative sign here and a positive sign here, which makes sense.
It's like you have there FBA and there you have AB. It's like the original.
I ask what the force that B apply on A.
Yeah, but then you have A on B. So
What? Oh, here. Okay. Good. Really good. Okay, thank you very much. Thanks. And let's just write it like this. B on A as a summary is K, Q, 25, 0.6 minus 0.8. We're going to use it later on. Okay? Yes?
Do we always need to normalize the direction?
No, it's up to you. If you like it, if you don't like it. What?
Until we ask, we haven't.
If you're going to ask to do that, of course you're going to do it, but I some of the time doing that. I just want to show you that I can do this step, that's all. Okay? Good. The next question I'm going to ask you is that. I want to ask you, what is the electric field that charge C put in the world? What do I mean by say electric field? When you put charge inside the world, okay, you create a field. This field tell us what's going on with the forces. We're going to see what's going on. What I want you to know is, let's go there. If, let's say that they were positive, okay? I don't say they are positive, but if they were positive, this is negative, right? So I want you to think about electric field like a flow, okay? So positive is kind of a tap. It's pull water outside. That is the electric field of a positive charge. And if you think about the sink is actually a negative one. It's actually taking all the water from the world, okay? So that's what you need to know about electric field. And what is the term for electric field? We're going to write it here. So the term for electric field, it goes like this. First of all, you're going to have K, the constant from experiments. You're going to have the charge which produce this field into the world, which is called QC. You're going to divide it by a magnitude, X, Y. Remember, this is all over the world. I put some charge, all the world changed. All the world sense there is a charge over there. When I came with this pole to this thing, when I charge it, the world changed. I put electric field in the world. That's what I did. Okay? So X, Y, a general vector, minus the location of the one that project this electric field to the world. Right? Multiply by the vector. Remember, electric field is a vector. Okay? Multiply by the vector X, Y. Let's do it with this big here, xy minus rc vector. Okay? Is it clear? So let's find what the value of the electric field that C is producing and going to this board. So if C is actually a negative sign, so it's going to make something like this. You're going to suck up all the electric field that he can find in the world. You're going to pull it, attract it to himself. Okay? Good. So, you know what? Let's be, okay, do it like this. So the only thing that we need to put here is QC, which is huge, right? It's minus 20q, right? K stay the same, right? And down below, this is a general vector, right? I forgot here to put 3. Okay, note, put here 3. Minus the location of the one that produced the electric field. Where is C located? 8 plus 8 and 6, thank you. 8 and 6 to the third, multiply by this vector. X, y, minus 8, 6. Okay, this is a formula you can use. It's ready. Boom, you got it. And what this formula is good for? It's good for to ask what is the electric field in that particular place. What is the electric field here, in this location, right? That's the idea. So that was question 1b, let's call it. This was 1b. That was, the first one was 1a. Let's solve 1c. So I'm here. Okay, so 1c gonna ask, what is the electric field, not in general place in the world, the electric field in the location of A. What is the location of A? The easiest, yeah, the region. Good, okay? So here. So we're gonna take this term and just put the zeros inside, right? That's all. So we're gonna have this thing. Note that I don't care about the charge of A. Okay, I don't see it in the formula, right? Good. So we have K. We have minus 20q, right? Down here we have, how I told you that I'll have to solve it. I'll have, first of all, solve this term, right? This one. So it's just minus 8 and minus 6, right? What's the magnitude of this term? I'm going to do Pythagoras, right? And this is equal to 10. Okay? It's really a nice one. So 10 to the third, that's all. And what's it going to end up with after organize it? I'm going to get kq divided by 5 multiplied by 0.0, 6.6. Okay? So this is actually what's EC apply on the location A, and this is also a vector. Clear till now? Good. Now I want to ask you, what is the force that charge C put on A? Okay, let's go here. What is the force FC? This is going to be 1D. 1D. What is the force that C apply on A? If only C was alive in the world and also A, B does not exist, what was this force? Okay? And now I want to teach you a really easy formula. Okay, really important one. If you want to see what is the force that apply on somebody else, you don't need to use this big thing. You can write, first of all, QA, the one that's going to suffer from this force. And here you can put the one that produced the electric field on the specific location. You got it? Okay? This is Coulomb law. That's the idea of it, okay? If you want to move from electric field to force, you're just going to say what charge actually fill this electric field. Got it? Since we found that, this is a given, we found that at the location, it's really easy to find the solution. So it's just taking that and multiply it by QA. Extend it by QA. If QA was really big, it means it's really sensitive to electric field, to this phenomena. If it was having no charge at all, I don't care there's electric field, I don't feel it. I don't sensitive to it. That's the concept, okay? So we have this term and this term. QA is equal to what? 5Q, thank you. 5Q multiplied by this, KQ divided by 5, 0.8, 0.6. So this 5 and this 5 dies out, and we get the solution that the force, right, the electric field. So the force, this one, the force C on A vector of course, is actually K Q to the power of 2 multiplied by, and what we're going to do after we find the solution? I forgot the minus, I think, right? Ah, no, it's already there. Okay? So what we need to do after we find it, we need to check that the signs make sense. Okay, let's go there. Okay? So if these two, cameramen, are you with me? Yes, thank you. So I go into the board, and if these two have a different charge, right? So they're gonna attract each other, yes? You can think about it female and male and stuff like that, but you know, it's really, really dumb it down. Okay, so this thing actually tried to pull A. So I expect to have a positive X and a positive Y. This is the force, right? That A feels, A senses because of C, okay? So what we have here, good. We have a positive at X and a positive at Y. We are good to go. Perfect. Okay, I want to ask you another question. So let's go here. Okay, so now I want to ask you, what is the total amount of force that charge A sense? Which mean, I'm going to take it down, which mean, where is A gonna go? Okay, that's the real question. If I feel force, I'm gonna go somewhere. That's the idea. This is the reason this thing turn around, because it feels some force. So for here, we need, so the question is, what is the force on A? The total one, right? So this is actually gonna be a really easy question, okay? For solving that, we're gonna use a really important idea, which called the superposition. The superposition gonna help us a lot of the time. What is the superposition principle? It said, let's take hard, really complicated thing and dumb it down, okay, to its component. So the force that I feel here is actually comprises of all the charges that surround me and apply this force, which means count all the people that actually apply force on me, right? And I'm gonna count. Yeah, I'm gonna count all the creatures in the world that apply force on me. For example, if I'm gonna play, okay, with my cousin, with my nephews or my cousins, so they're gonna pull my hair in that direction. This is one force, and another one gonna pull me there. Where I'm gonna go? The summation of the vectors, right? That's the concept. That's the idea. If this one try to push me there, and this one try to pull me there, the effect gonna be the summation of the vectors, okay? If I'm gonna lift some of you, I'm gonna feel your weight, and if I'm gonna put something else on that, so I'm gonna feel both of you. It's gonna sum up. So what are all the forces that apply on A? We have B, which we already found it, right? So we have F, B on A, right? This is this term, we found it. And we also have the contribution of C on A, which we already found. It's over there, right? So if we're going to sum the two of them, that's it, okay? We're going to find everything. So we're going to erase this thing. So let's write this explicitly. So the force on A, it's this force, let's write this first, K q squared divided 25, 0.6 minus 0.8 plus, right, this force, which is K q squared divided by, not divided by anything, great, okay, multiply by 0.8, 0.6, and what I need to remember is that I'm going to sum x with x and y with y. It's a vector summation, right? Don't forget it. Good. I also see that this one, two of the terms have the same constant before them, so I can drag it out. And eventually, I'm going to get the force, this one. I'm going to get 1.02 kq squared multiplied by 0.9 and 0.4. That's all. This is the total force. Okay? What this means, that where's the particle, where's this marvel, this, small charge going to go? In this direction, right? And so we can see that who is going to govern this equation? Where is the charge actually going? C, right? We see that C has much more power. Okay, this is the bully kid from the kindergarten, right? He can do whatever he wants. He's so strong. He has such an enormous charge that he actually governs whatever is going to happen. Understood? Yes? Great. Last but not least, the thing that I want to finish with, it's kind of a hint for your homework. Okay? Something that's going to help you. So, I'm going to take marble B outside of the picture. I'm going to change it. I'm going to put something else. Okay? Let's go to the picture. I'm going to go there. Okay? So, I'm going to clean marble B. And I'm going to put another marble, which let's put it in this way. A new marble, which called capital B. Okay? A new one. Okay? She's still shiny. Yes? See this? Okay. So this is marble B. We don't know what is the charge of marble B. We don't know. This is what we need to find. Okay? But they're giving us a hint. They're giving us something that if we're going to use, we can solve the problem. They're telling us that marble B going to roll only, sorry, not this way, going to roll only at the y direction. What does it mean that it's rolling only at the y direction? There's no force at the x direction. The x component force on marble B is 0, is none, it's not exist. If it were exist, even small, there was some movement at that direction, right? So every time you hear something that is static in one of the direction, aha, the total force is 0. Okay, that's what I want to pop out. Okay, so I know. Okay. Sorry, I didn't. I need to put it more clearly. Okay, not marble B is not moving. Sorry for that. I meant marble A is moving only in this direction right now. Okay. Good, got it? Only this one. So the same thing applies. So I know that the x component of A is actually 0. Good. Okay. So what is the force on A? What is the force on A? Is comprised of, good, the force that B, the new B apply on A, and also what C already doing, right? Good. And we know that the x component of that, if we're going to put here x's, I know that the x component of these vectors actually what's? Equal to 0, actually canceling out each other. That's the concept. Got it? Good. So if we're going to compare between the two of them, so it means, let's put here KQB multiplied by QA, right? Divided by 5 to the third, divided by -3. Why only -3? Because it's one direction. We're dealing with the x, right? And this is a plus. I'm going to put this one. It's K minus 20Q. I don't know what this is, but I do know what this is. QA divided by 10 to the third, and again, only the x component. Right? That's what I have, and this is equal to 0. Note, I don't care about the charge A. Charge A not going to play. It's a battle between this one and this one, right? This is the fight. Good? And if you're gonna, it's just, you know, one component. You can also divide by K, you see, okay? And the result for that is QB end up to be 4 divided by 15 Q, okay? Got it? Okay, good. So what we did till now, we deal with the point charge. And we know in life that stuff not always, you know, concentrate in one point. Usually we can say that stuff is in one point if I'm looking for really far away, right? Even Earth can look like a particle if you're really far away. But if you're going to be close to an object, for example, this thing, which we're going to deal next time, a cylinder, and we saw in the first tutorial how charge distributed around many objects, so we need to take care of the shape of this object. Okay, so Can you stop the video and let's do a new one, okay? I'm going to go